My name's Joe. I'm the Chief Technologist for EMEA for VMware. I sit in the office of the CTO, and my job is to work with our customers and partners, and more importantly, internally, on the strategy of where we're going to be in 3 to 5 years' time. Problem is, no one knows where you're going to be in 3 to 5 years' time. If I did, I wouldn't be giving this presentation. I'd be dialing it in from my boat in the Med. So a lot of this that we're doing is sort of high-speed conjecture and following markets. VMware's done that rather well. We're currently running at over $4 billion of revenue, and pretty much every company in the world now runs VMware at some point somewhere in their company, which is not too bad. Now, at this point, usually as a speaker, you try and establish your credentials as an experienced technologist, and so I thought I'd do that very quickly with you now. I'm a second-generation technologist. My father was at IBM for 32 years, lucky enough to have a final salary pension. There's swear words that go with that. And so I have some really good heritage, and one of my favorites is this picture that he dug out for me recently. That's me in the middle. I started out blonde. And I'm age 4. I'm at the IBM company party playing tug of war in an IBM DPCE T-shirt, and which I think I've still got somewhere. The cable that we're using for tug of war, you'll notice, doesn't have an ordinary rope ending on it. It's an IBM 360 mainframe interface cable. They couldn't find a tug of war rope, so my father went to the demo lab and stole the mainframe interface cable from the demo suite, and we used it all day for both child and adult tug of war, apparently, put it back again, and it still worked. So I think it's probably still installed somewhere right now in a bank. Knowing what they're like. I do actually know of a bank that I worked with in the 90s, and I do phone them up occasionally to double-check, to talk about the stuff we keep behind, which I'm going to do in a minute. They are still running their core overnight batch reconciliation processes in pounds, shilling, and pence, which they then put conversion algorithms on. It's running in 4 levels of mainframe emulation as well, because they daren't touch it because it works. So that's worrying for me. So I'm here today to talk about really how technology is changing the face of business. And it's really a very simple story. We went through several phases of IT. The first phase was the heyday of we are automating manual processes. Budgets for IT are pretty big. You can just buy as much as you want because it's saving the company money. And that carried through until sort of the late 80s. And then we started having these conferences where people talked about doing more with less. And people started talking about how we can be more economical in how we use IT. And IT had no longer become something that we used to compete with and to get ahead of our enemies, so to speak. It actually just became a necessary evil. And then there's been an explosion in the last few years of people, again, using technology as a weapon. And there's a few examples of those companies that didn't. And when I go around, and a lot of my job is actually talking at CIO forums and having meetings with the CIOs of our large customers, there's 2 types. It's very, very clear-cut, to be honest, and it's based on reporting lines. If the CIO, or ultimately the IT department, whatever they're called, report directly into the CFO, that organization is probably a cost, it's embodied as a cost, and people are looking at ways to reduce that cost. If the CIO or the IT organization reports into the board, or not through the financial organization, then it's got a better chance of being an organization that's actually looking to use technology for change. And more importantly, tying technology to revenue. And that's usually quite a good indicator for our sales force when they're talking to people, is they can work out how hard the sale is going to be when they're going in and what the sales angle is. And it's one to bear in mind yourselves. Recent years is now littered with the dead bodies of dinosaur organizations that just looked upon IT as a necessary evil, whilst other people found new and innovative ways to use IT to beat them. And I don't need to give you a list, but you can probably think of them yourselves. These were companies that thought that IT was not something they needed to actually do their business in terms of competition. It was just something that enabled their business. And I challenge you to think about, as we go through this, and the one thing to take away is, are you looking at IT in your organization as just how I can upgrade to the next version of whatever? Or are you looking at it as to how I can do something with technology to directly affect the revenue of my business or the performance of my public sector organization or whatever? So we're in a period of massive change. We've got 3 major trends going on, really. PCs are turning into mobile devices. I spend a lot of time with the telcos, And they're becoming data operators. They don't do voice anymore. It's almost a side effect of what they're doing. Realistically, they're more focused on how they're going to cope with the increase in data. Applications, what we used to call applications. Now, this is interesting because I talk to different people in different parts of the business, and when you talk applications to some people, they think you mean Microsoft Office, and other people understand that we're talking about applications such as line of business applications, your Siebel, your PeopleSoft, your custom developed applications, the ones that actually run your business, which in some ways actually could be your mail system. These are moving to new style applications. They're moving to trends around big data, which is the latest craze term invented by marketing people to make you all get excited about buying technology. And then down the bottom, servers are turning into the ultimate oversold term of clouds. Now, what's actually happening is quite interesting because we've been oversold on cloud, and I've been playing in this area for a very long time, as I'm sure you can imagine, and I tend to hear or see at least 2 definitions of cloud per day in some ways or other, so I'm not going to do that for you now. It's sold to you as something that is self-service, instantly provisioned, pay for use, efficient, scales up and down, it's awesome, it's going to change your life, everyone should use it. Reality, from a technologist perspective, and I can go into the whole economics, etc., a bit later on, but reality, you're looking at 2 things, 2 big trends that are actually hitting our industry. The first one is in software, where monolithic applications, your classic monolithic stacks, are moving to distributed services. Fantastic new words coming out that you probably never know or heard of. At the same time, platforms are moving from loosely connected discrete resources with fantastically great and over-expensive integration projects to virtualized fabrics of resources. That's really what's happening in technology. That's what started cloud, is this drift towards things that are not stuck in one rack or one cabinet or one stack or one lamp stack. Really, you're in IT to do a very simple thing. Provide platforms to build services upon. Back in my father's day, someone would come along and say, we need an accounting system. At that point, the platform for the IT department was the data center floor. And they built everything from the data center floor up themselves. What's happened in recent years is the choice of platforms has massively diversified, and also your level of entry in terms of platform choice has changed. Software as a service being at the top, but you've now got platform, infrastructure as a service, and other hybrid pieces in between that. So if we look back and look at what's actually happened in our industry, realistically, the trend is around a very, very simple 3 words. Abstract, pool, and automate. We've been doing it for a very, very, very long time. We've been abstracting from a particular layer in our IT infrastructure, pooling it together, and automating its delivery. And this really has been going on since the mainframe days, but certainly in the x86 platform, it's been slightly different. So if we look back at when someone came to you and said, I need an application, I don't know, some CRM system, please, for my salespeople, back in the early 80s. And so you said, yep, fine, I can do CRM systems. Right, now we need to go and look at what servers we need. And you finally choose a server, probably a mainframe, back in those days. And then you'd get some storage to go with it, tied to that mainframe, dedicated to that job, and then you'd run your application. And then, a couple of years later, they'd come along with a request for another app, and another app, and another app. And eventually, you'd have something that was maybe a bit of mainframe, AS400, Unix open systems, and then some Windows servers, which probably started out as Novell or OS2 servers at some point. And you now have what we in the Office of the CTO at VMware call the Museum of Past IT Decisions. Or you might call it a data center. Now, there's nothing wrong with any of the decisions that were made. Okay? They were all valid at their time. The problem is we've been building ourselves up into this collection of silos with specialization and specialized hardware. We've been doing things a very, very old and wrong way. So the first thing when we started this abstract pool and automate was when someone said, hang on a second, if we get all the disks, right, and we put a layer on top of the disks that makes all the disks look like one big disk that we can then carve up and hand out to people, wouldn't that be a cool idea? And so they did, and it was called RAID or SAN or NAS or virtual storage or anything else that had been invented as a marketing term for you. Think about your cloud definitions that you've probably heard 100 times. It's elastic. You can add storage to it. Yeah? You turn up and you request the service from your server. You don't request a particular type of disk or particular speed of disk. If you do, you're doing it wrong. It's designed for failure. It's fault tolerant. You can lose disks. Doesn't matter. You're turning into a commodity consumption in terms of the disks. There are lots of cheap rubbish disks rather than one big expensive disk. It was the first real cloudy type of service. It's just we didn't call it cloud back then because the marketing people hadn't got to it because it was a bit too deep into the data center and they were too busy with their coloring in. So we then turned up and we built our servers on top, and on top of that we put our applications. And then, myriad arguments about this when this was, but let's talk about x86 platform. x86 platform was really us at VMware with the growth of a project out of Stanford University. A lot of the team is still with us, where we then put a hypervisor on top of all of your servers, and that has over time grown to be called infrastructure as a service. But in essence, what we did was we said, okay, fine, we're going to put a layer in. You turn up and you request not a particular blade. If you're doing that, you're doing it wrong. Okay, we just request the ability to run a VM of a particular size. All the things like fault tolerance and load balancing and scalability are done by the platform that I'm running on. I just get my VM and then I run my app. We're abstracting, pooling, and automating as we go up the stack. So what's next? Because we're having these infrastructure as a service wars now. You'll hear lots of talk of OpenStack, CloudStack, OpenShift, no, that's up at the PaaS layer, our own vCloud, you name it. The next fight is at the PaaS layer. And that's where you put an abstracting, pooling, and automating layer on top of the VMs. And then you turn it with your applications. And that PaaS layer does all of the fault tolerance, the scalability, the load balancing for you. You don't have to code it yourself as a developer or even think about it as an architectural decision. The interesting point here is that then commoditizes the VMs. In our PaaS service, Cloud Foundry, these are all identical nodes. There's no patching, there's no upgrading, all that kind of stuff. If we want to upgrade the system, we just kill off some running VMs and replace them with newer VMs. And when they're all new ones, kind of like a blood supply, the whole system has been upgraded. The system is built and designed for the fact that any one of these things will disappear at any time, much like this is designed for the fact these fail, and this is designed for the fact that these fail. It's one of the key fundamental tenets of building a cloud system. So you can turn up with your application, and what you worry about has got less and less and less. So now if you want to write an app, you turn up to a platform as a service layer, and you just run it in Java, Ruby, Scala, Rails, Grails, you name it. Challenge is, your choice now as an infrastructure person or as an IT person is what do you care about anymore? Now, if you think back in history, we used to care about the hardware. We used to care about all the power supplies and all the redundant failover stuff. We used to care about the manufacturer of the motherboards. Remember when you used to care about the manufacturer of motherboards? Yeah? Remember when some people used to care about the manufacturer of the resistors and components on their motherboard, but we all stopped that a long time ago. Now we've got to the point with this where we pretty much don't care about the manufacturer of our servers anymore. It's just commodity tin. Slide in some x86 boxes and we'll use them, okay? And so as we move up, what you care about, or what we call the FRU, the field replaceable unit, gets larger and larger. And that's why you're now seeing people like VCE, ANS, HP, and others bringing out, and Nutanix is probably one of the most interesting ones, bringing out hyper-converged or converged infrastructure units, where they will ship you a rack which has the storage, the compute, the networking, and everything built into it. You just turn up with your VMs and run it. So it's basically everything from here down in one box that you buy as a managed service as a piece of hardware. It's kind of like the mainframe, actually, going back if you think about it. And the challenge we're having as our industry is letting go of stuff. Okay, we're pretty good at holding on to stuff in IT, as you can see from your own data centers. But we're also pretty good at thinking we need to worry about stuff which we don't need to worry about anymore. Great example is the CTO of VCE told me that one of their customers made them laugh. He went and did a sales engagement with them, and they turned down the vBlock, the integrated vBlock. And when he asked them why did they turn it down, he said, well, is the reliability not good enough? Is the service not performing as you want it to? Is it something to do with other SLAs? Is it a speed issue? The guy went, no, it's got Cisco UCS in it, and I don't like Cisco. And that, to me, was just mad. That's like saying I don't like this Volkswagen Golf because it's got a Bosch ABS controller in it. And when I used to build my own cars, I never used Bosch ABS controllers because I didn't like the manuals, right? Does this sound like something you're doing in your organizations? Do you differentiate your business on whether the fact that you can specify SCSI cable lengths better than someone else in your industry? Hardware manufacturers do. That's their job. You don't. Think about that. Think about what the platforms as you go forward that you're going to choose to build your services on. And think about what the value is that you add as an IT organization. Is it in building infrastructure? Yes. Great. Go and become a service provider. So what we're looking at as we go forward is this sort of one data center platform for all. How do we get away from all of this continually building new stacks? Now, in some ways, this is an answer, okay? Because we're now building one platform here that we can run all our applications on, or one platform where we can run all our VMs on. And interestingly, by the way, all the money is in these pieces. The money is not in these commodity pieces, and you can see that if you look at what's going on in our industry today. And as we go forward, you'll notice everything has moved into being done in software, not in hardware anymore. We don't do the reliability in hardware. We don't do the load balancing in hardware. We don't do any of the stuff in hardware really anymore. So we're looking at this one data center platform for all concept. And how do we go forward to build a platform that will take any load of the future? Well, the answer, obviously, is to abstract, pool, and automate. But you need to abstract, pool, and automate all of the three key services, both compute, storage and availability, and networking and security. Compute's done. It is done for pretty much everything. VMware now, we're properly into edge cases of virtualization. And I'll talk about those in a sec. But what we need to do before we can adopt and use this technology is change the way we run our IT departments. Now, business, and I'm talking general business, not IT, has transformed dramatically in the last 100 years. IT needs to as well, and we haven't. In fact, in some cases, we've taken retrograde steps and even put handcuffs on ourselves. So the first real trend was containerization. Now, those of you who are into the history of shipping, as I am, will know that in the early 50s, ships had dedicated loads, dedicated trucks, dedicated trains for particular types of load and cargo. Interesting, isn't it, that stuff that goes by ship is called cargo and stuff that goes by road is called a shipment? You get that? But a guy in the 1950s came up with a really good idea. It's one of those fundamental wish I'd thought of it, like the paperclip, right? What if we put everything in the same size box, and then we just build things to move those boxes around? And that's where we got to today. What he did was he disaggregated the hardware from the load, okay? He took the loads that were being carried, put them into identical or very similar size containers. You can get different sizes of containers. They're 20-foot or 40-foot. I think there's 60s now as well. But essentially into the similar size system that can then be moved around more easily. You see where I'm going with this? Because when you look at IT, that's exactly what we're doing with virtualization. Virtualization is the shipping container of our industry. We're taking our workloads, we're putting them into containers so that they can be more easily moved. We get choice of where they run, i.e. what hardware they run on, and we get better insight into how they're running because we can lock them up. Trend Micro do a product called Deep Secure, which is really cool, which is essentially a full combination secure lock that goes on your container. And wherever you ship that around the world, only you, if you've got the keys, can go and unlock and use that VM. So the ability is there to take your workloads and lock them up. Yet we're still tying, in most cases, our workloads to particular types of ships and particular types of trucks. And that's restricting our ability as an industry and as businesses to innovate and be agile. Automation's a key favorite of mine. I was an admin back in the day, funnily enough, internally for HP. And automation still hasn't moved on in 20 years. Automation for a lot of organizations is I wrote a script. Cool automation is I wrote a Perl script. And then I put a Java GUI front end on it, so it's kind of web-based, isn't it? But that's not actually automation. Automation as we think it in IT has been focused on process. And that's kind of like Henry Ford when he invented the first production line. The production line was a great idea, but it wasn't actually automation. It was getting everyone to stand in a straight line and then pass the workloads past them. It made it slightly more efficient, but necessarily more rigid. kind of like ITIL, right? And if you really wanted to make sure no one ever came up with a really good idea, you then applied Six Sigma to it. So if you go and look at Toyota or Mercedes, automation in their factories is where you've got machines doing the work of many at speed and at scale. And in IT, we're pretty bad at that because people are quite good at guarding the information they know and keeping their job by not telling anyone how to do things on particular systems and not automating it. But if you want to go and operate as one of our customers does, operates a cloud that supports one of their services on their phone systems that happens to do voice recognition, you may have used it. That's running in just under 200,000 VMs. You can't manage 200,000 VMs with people. Those VMs don't even have names, really. Remember when I was an admin, I used to know the IP address, the name, the location, even the model number of every server I managed. Not anymore. Not when you've got a guy who's got to manage 1,000 servers or 10,000 servers. It's a different type of automation required. You're moving from these traditional IT silos, these traditional, the network team, the storage team, etc., and you're turning it into cloud infrastructure teams. And this isn't conjecture. I sat last week with one of the major investment banks and chatted to their new head of IT, essentially, is his job, some convoluted title because it's an investment bank. They don't even like being called an investment bank anymore. They're a bank with an investment arm. And they have completely changed in the last 2 weeks their entire IT organization. They've got rid of the storage silo, the network silo, the database silo. What they've done is they've got 4 teams. The end-user computing team, the applications team or platforms team, and the infrastructure team. And then they've got a shared services team. End-user contains what you'd think it would contain. Platforms contains both the developers and the database team. They have to work together. You don't develop something without data. The infrastructure team contains not only the compute, but also the storage and the network in one managed group, providing services to the tier above it. And then the shared services stuff is actually, you think, well, hang on, if all that's there, what's left for shared services? Things like directories, PKI, stuff like that everyone uses. This is happening now as people start to reorganize their silos and get rid of people being locked into things. Because the interesting one is, if you're trying to do an upgrade and you're waiting for another team cycle or you're trying to roll something out and they've got to wait, that's when things take forever in IT, and I'll talk about that in a sec. Standardization, I'm talking about standardization of process and components in what you do. So if you think back to the 1800s, and when they were first building steam engines, or machines as they were in the early days, if you wanted to build a machine, you had to build everything for that machine yourself. You even had to go and make the nuts and bolts. And then people came up with standard threads, Whitworth and others, for those of you who remember that kind of stuff or did that at school. And once you had standard components, that drove innovation and allowed flexibility because you could innovate faster because you weren't actually wasting your time making menial stuff. You were getting on and making the interesting value-add invention section. And so in IT, we need to move to standardization of components. We need to move to the fact that when you want to do something, you're picking from a list of standard things and putting them together, and the putting them together is the value that you add. For your organization, it's what are those components? What is the field replaceable unit for you? But you need to abstract, pull, and automate in what those components are as you go forward in building value in what you're doing. Globalization is an obvious one. I mean, globalization has utterly transformed commerce. I can get a rather cool remote control helicopter shipped to my house for 20 quid from China direct. That's less than it would cost me to actually make and source the components locally. That's globalization. And large companies are taking massive advantage of that in their manufacturing. You'll see Land Rover themselves have just got approval to go and launch in China. Globalization for IT means making sure you have the ability to take advantage of workloads and availability to use those workloads anywhere in the world. And that's what's emerging now. Amazon's a good example with their few availability zones around the world. We have our own vCloud. vCloud is a standard that we ask service providers to stand up to, And currently we have certified for vCloud over 150 data centers in over 30 countries, totaling 1.27 million square foot of data center space, all ready to accept a standard VMware VM from our vCloud technology on site. Click and drag your workload into their data center. We've got tens of thousands of other service providers that use our technology as well. But that's what we're talking about. Those are standards that are already there that are aiding globalization. But all this heads towards what the real rub in IT is right now, which is markets of one. Now, markets of one is a marketing term, and to translate it for you very simply, it's the fact that we've gone from a situation a few years back of a few markets of thousands of people to now thousands of markets of the few, down to markets of one as a destination. And that's talking about the fact that Amazon, when you go and work with Amazon, for example, and you go and buy something from Amazon, that experience is dedicated, focused on you. You feel like you're getting a personalized service built around yourself. You feel like they've done something special for you. It's why you go back. Whereas you go to that other website where there's no personalization and you just feel like another peon that's buying stuff, and then eventually your business folds because people don't feel personalized. This has hit the car market dramatically in the last 30, 40 years. I think it's Vauxhall have just announced a car. I can't remember what it's called. But it's got 1 million different ways of configuring it. 1 million different ways of order choice. Mercedes is nearly that, right? And so you can pretty much guarantee that you can go into one of these car showrooms and specify up a car to your specification with the pink leather headlining or whatever it is, and know that that car will be pretty much unique for you. But that company can build it at a price that's acceptable to you, in a time frame that's acceptable to you, because they have standardization, they have globalization of supply, they have containerization in what they do, and they have automation. That as it comes along the production line, the robots do different things to it based on what it is. But they're still the same robots with the same standard components doing the same job, they're just configuring in different ways. The challenge is in IT, we've never made that step. We've never realized that the people that work for us are all slightly different. What we think is that they all want exactly the same XP desktop, and they all want exactly the same CRM interface, and they all want exactly the same experience because they're all doing the same job, aren't they? Well, they're not. They're all doing it in their own different way that makes them productive and unique. And the challenge now is the fact that the enterprise is the little guy in technology. Apple's revenue on iPhone alone in 2011 was more than Microsoft's total revenue for the year. Okay? There is more technology now in the wider world than there is in the enterprise. We know that. This is the whole bring your own device thing that everyone talks about. The rub isn't around the fact that people can bring their own device. The rub is that they bring their own device into a very fixed and rigid world that is not agile and not focused on delivering to the markets of one. And that's where things start to rub up against each other. Because if you don't start providing these services in these ways for your users, they will take the path of least friction. And the path of least friction for them is the problem you've got. Dropbox and all these other different systems that they use. Why do they use them? Because they're easy and they work. Not because they're digital natives and all this other kind of stuff. It's because they're easy and they work. That's why we use them, right? That's the challenge you've got. A workforce that's educated, a workforce that is aware of what it needs to do, and is aware of the options more than ever before. What you give them isn't necessarily the best thing they're going to get. These guys are built as digital natives. Digital natives is a funny one because I hate those Generation X, Y, A, B, Z things because they always exclude me. And I consider myself quite techie. But I was blown away by my 9-year-old daughter about a year ago. We've got these showers in a new house I moved into. They're Aqualisa showers. Have you seen those? They're quite cool. You press a button, and the button flashes until the shower's at exactly the right temperature, and then you can go in and have your shower. It's fantastic. You can even get a remote control to put by your bed, so you don't have to get out of bed to activate the shower. Right? Very cool. My daughter came down to me one evening when she'd been sent up to go and wash. She's 9, you have to do that. And she came down to me and she didn't say, Dad, there's no hot water. Dad, the shower's broken. No, she said, Dad, the shower's not loading properly. Right? Because that's what everything does in her life, it loads, right? These are the people you're dealing with. And these are the people you need to change your business thinking to support. So the fundamental piece you need to do to support these is the software-defined data center, and this is the term that we've invented. And really it's about the fact that everything needs to move to software. And it's not just because we're a software, it is because we're a software company. The problem is very, very simple. You've all used virtualization at some point, okay? And there was a promise. The promise was that we're at a sweet spot for IT right now. x86 price performance is actually going up. I don't know why the arrow comes down. It's a bit strange, but the price performance is going up. I've got a customer that was, it's a really funny story, an airline, and they had a system they ran that was running on PowerPC, and it was taking 12,000 seconds to do the job. They were kind of happy with that. They got used to that. They built processes around the fact it took 12,000 seconds to run this job. And then they were in dev and test, and so they spanned this system up on some x86 virtualized instances on some cheap hardware they had lying around in the test lab. It took 900 seconds. They went from 12,000 to 900 seconds in their test environment, and that's when they suddenly thought, hey, hang on, maybe we're doing this wrong, and changed it. This price performance is phenomenal now. At the same time, we've got virtualization for all apps. As I said earlier, we're on the edge cases now. We're looking at HPC, and we're looking at low latency. We're having arguments about the speed of light, which is really interesting, actually, to have arguments about the speed of light. As a scientist, anyway. Interesting side fact for you. 1 nanosecond is 1 gigahertz, okay? How far do you think light travels in 1 nanosecond? Anyone know? Anyone good enough to do the maths in their head that fast? About a foot. Spot on, sir. 30 centimeters, okay? Pretty much.
I used to be very research.
Well, I mean, this is it. And in the old days, actually, you used to change the performance of machines by cutting the cables to different lengths, right? So light travels a foot or 30 centimeters in a nanosecond. So if you've got a 1 gigahertz processor, the fastest you can put the furthest away you can put something from that to talk to that at 1 gigahertz is 30 centimeters. If you've got a 10 gigahertz processor, it's 3 centimeters. This is why you're not seeing processors hit the point much beyond 10 gigahertz, because we get to some really interesting physics. Because it's not actually 3 centimeters, it's less than that because of the transmission in copper and a whole bunch of other weird stuff. Okay? So that's why you're seeing now the world is scaling out. And contrary to some other companies' belief, you can't just go on building bigger and faster boxes. We have to build more boxes sideways. So we're now looking at low latency stuff, and speed of light arguments, and high performance compute, the blue gene things. And at the same time, we're doing virtualization of pretty much every hardware component as well. SRIOV support in the latest version as well for network card virtualization. So we're facing a problem. In the past, it cost $10,000 and took 10 weeks to provision a server. And we came along with virtualization and said, you know what? It's going to take 2 minutes. It's going to cost you $300. And everyone went, ooh, awesome. Virtualized everything. Reality? Not the case. Okay? Yes, we can provision a VM for you in $300 in 2 minutes, but because of all your ITIL, Six Sigma, and all the other processes and the way you've put everyone in silos, it actually then means that it takes 5 days and 2 minutes to do it, because once you've spun the machine up, you then have to argue with all of these other teams about what port address it's going to have, what storage it's going to have, what network it's going to be on, how it's going to be configured for security and load balancing, and all the other kind of stuff. Yeah? I was in an organization, government organization recently. They've moved to virtualization. It has shortened their provisioning time from 6 months to 4 months. Okay? Process is our next challenge. So our job now at VMware is how do we get that 5 days, 2 minutes down to a fully virtualized software-defined data center where you can provision an entire VM in 3 minutes. So the definition of a software-defined data center in our book is that all services are delivered as software, and the control of this data center is entirely software-driven. Okay? So the idea is we take your existing siloed applications. We've already done the compute piece. We've put that into one nice big automated abstracted pool. And then we're going to get your storage and virtualize that. And you're already doing that with a lot of storage vendors today anyway. The next tricky piece and the fun piece is virtualizing the network. Once you've done that, you can get over the major problem we have today in networking. We came along again with vSphere and said, it's brilliant. You can do operational simplicity, operational speed, vendor choice, hardware efficiency. You can spin VMs up. You can move them around. You can fail them over from one data center to another. It's awesome. It's in a container. Do what you like. And then the network team came along and said, no, we're going to physically tie it to a particular VLAN with an IP address. Sorry. So all the stuff you wanted, can't really do. Basically, you just added a layer of complexity to your server stack. Nice. And we want to try and solve that. So to solve that, you need network virtualization, which is kind of software-defined networking, and that's another definition argument going on right now, but it's a bit beyond software-defined networking. So you create your logical network on top of your existing physical network. All we need is an IP transport. Existing network is fine. We then build the entire network that we need on top of that virtually. Then we insert all our software-defined network and security services from VMware and partners. And we can pretty much do anything as a layer 4 to 7 service, and even below as software. Most of them are software anyway. Firewalls, mainly software. On commodity hardware, there's less and less ASICs. Load balancers, same job. Even looking now at MPLS CEs. There's something that we can turn into a virtual appliance. Pretty much everything can be made into a virtual appliance. They're software anyway. And then, using policy-based automation, you can build your virtual data centers on top. So the break is really kind of like when we broke away from having physical locations for our phone. When you phoned a number up, you knew where it was, and that was that house. Much like today, when I go to an IP address and I know that VM is in that location, to wireless telephony, where a phone number is associated with a mobile phone that can freely roam anywhere, and the network sorts out making sure its number still gets the right number and routed and data and everything else. That's what we can do with virtualized networking. The ability to take a VM and have it moving massively around the world without worrying about where it is, because the network, the virtualized network, sorts out stretching your VLANs across, and it's not actually stretched VLANs, it's VXLAN, slightly different. For the real techies amongst you, it's wrapping layer 2 and layer 3. Once you've done that, hopefully you can reduce the number of admins, which isn't actually reality, by the way. No one reduces the number of admins. You just get your existing number of admins to manage more stuff, because that's what's actually happening. Okay? So don't worry. No one's going to lose their jobs. No one's knocking down data centers. Okay? Everyone's building them. And then hopefully you can virtualize your apps into this software-defined data center. So the idea being that in one physical location, you could have 2 different data centers defined, entirely separate. And yes, one of them could be finance and the other could be R&D, running on the same physical infrastructure, same physical hardware. Scary, huh? Dev and test and finance running on the same piece of kit. Who'd do that? Well, the British government do. Those of you who understand British government security, they are happy with running an IL3 workload and an IL0 workload, which is publicly internet connected, on the same physical virtualized host on vSphere 4.1. All approved. And being done quite a lot. So multi-tenancy is available and works. Then hopefully you can, do the expanding, identifying of hot VMs, the identifying of even the ability to create new space and expand them. But the real kicker comes when you turn up with a new VM. And that new VM turns up and it's dedicated with a policy associated with it. So this is a finance VM. And everything in that shows you where it ends up and how it gets configured. No one else has to do anything. It's automated. So that VM will land automatically in the finance place, and then we'll have things like storage, networking, firewalls, etc., provisioned to it by lasers, I think. It's a marketing slide. But in essence, that's what we're talking about. Everything is done in software. As one of the guys in our office calls it, clicky, clicky. He's not even Dutch. So this is where we're headed. Abstract, pool, automate. Not only compute, which we've pretty much got an A on at the moment, but also the storage and availability and the networking security. So everything is defined in software, built on your existing hardware, and then maybe commodity hardware after that when you get to it. Interesting thing that made successful virtualization on x86 was the fact that you didn't have to go and change your existing infrastructure. You could take your existing servers, put the hypervisor on, bang, you're done. That's the same with virtualized networking. And we acquired a company a couple of months ago for a small sum of $1.26 billion called Nicira, 70-person startup who are the leaders in this space with the founders of MPLS and others. defining things like OpenFlow to help us solve the problems for our customers. And so really, to sort of wrap up, we're famous for this, which is software-defined compute and memory, as it's now called, which is just virtualized computers as you'd know it. But actually, there's an awful lot of other stuff we do, which not a lot of people know about. So we now have the software-defined networking security. We've had a virtual switch, really interesting fact here. We've had a virtual switch in our vSphere stack for many, many years. We've not just got into virtualized networking. Someone asked us the other day, it was actually a press interview I was in, said, so how do you think VMware is going to cope with moving into the world of networking? We've been in networking for a very long time. In fact, before the acquisition of Nicira, by ports shipped, we were the third largest switch vendor in the world. We'd never made a physical switch in our life, but that gives you an idea of what's happening in your data center. By 2014, it's an HP estimate that 80% of server traffic in your data center will be server to server, okay, within the data center, probably within the same pod. May not even touch physical network copper because it's happening within the same machine array. We also have the storage availability and obviously the cloud management piece I talked about earlier, the vCloud stuff. Over here, a selection of tools around cloud operations management and automated provisioning. But the important one is this piece here. Another acquisition we did earlier this year was a company spun out of Credit Suisse called Dynamic Ops, which we've now renamed vCloud Automation Center, which, yes, does abbreviate to VCAC. That was an American marketing thing, not us. But that allows you to have one single portal to both manage and connect to your internal infrastructure, but also external vCloud service providers. And maybe if you, for some mad, wacky reason, wanted to use Amazon Web Services or even Windows Azure, if you're that brave, you could do that. And also manage other hypervisors, and also manage provisioning to hardware across one central point of GRC control. Okay? So your choice, really, going forward into this new world of IT, is look at your organization and look at whether your organization views IT as a necessary evil that we must cut costs from, or it views it as a weapon that you can go to the board with and show how you can directly affect revenue. I know which one I know would get investment in an infrastructure project is the one that goes forward and tells the company they're going to make money rather than going to save money. And with that, I'm done. Thank you very much.